To another problem session. So today we're continuing with torque and balance. So this is basically balancing forces and torques. We're going to return to doing more F equals ma problems, okay, later. But today we're going to do this, and maybe I'll do one more problem along the line of balancing forces and torques. Okay, so let's look at this problem. So you have this log that is mass m, and it is a cylindrical log. It's coming out, and you either going to do here horizontal, like it says, or you're going to push over here. So pushing tangential either way. You can try to see if you push over some random place. So you could say this angle is theta. So for this guy will be 90 degrees and this will be 180 degrees. So you can solve the problem with just theta. But I'm going to do A and B. So for you, the harder one to do is a better problem to do for F at some random point C at C. So this is for you. Okay, let's in each case we're supposed to find the force that will just push it over there. So let's do the first one, just A. So we have this log, and then we have this, and we have force this way. Normally, if not pushing hard enough, then you have force this way. You have a normal force from here, and the gravity is straight down, right down here. That will be gravity down here. mg. I like to use W because this is one letter and these are two letters, so as long as you can remember what's what. And then it's in contact over here. So there will be because not sliding, that means you can have some kind of a static or rolling friction, okay? Static friction, okay? And then of course towards the center will be the normal. This will be tangent, and towards the center is the 90 degrees. In a circle, right? In a circle, if you know, in a circle, if this is the tangent and there's the center, this is 90 degrees. Tangent and radial line are 90 degrees in a circle. Okay. So this is cross section is circle, and so we just use circle. And let's say this force, let's give it magnitude FA. Now, when it just pushes over, this normal will be 0. Just you think about an instant, it's just over, not touching it. So you might say it's like this, and this thing is just climbed over. It has a little bit of motion, but you can get as close to the surface except not touching it. So that's why this is just climbs over. So that means over here, not touching floor anymore. and that makes the normal to 0. That means normal from the floor. So there are two normals. One is normal this way, normal 2, and there's normal 1. So normal 1 will be 0. So anytime there are two surface contact, there will be normal to the surface. So you always beware. You have to have an argument whether it goes to 0 or not 0. But it's going to have normal. Okay, so here normal is 0. So over here, the only forces are these guys, gravity, and the normal, and the friction along this direction. I don't know if it's going to be this way or this way. We don't know yet. Okay, you can just take it this way if you want. Fs that way. And we need to figure out, this is the thing we need to figure out. So it is in static equilibrium. In a static equilibrium, there are only two rules, okay? Rule number 1, sum of all the forces equal to 0. So this is 3 equations. So like sum of all the fx equal to 0, sum of all the fy equal to 0, and sum of all the fz equal to 0. If you're thinking in terms of components, so it will give 3 equations like that. And number 2 rule is the torques about any pivot point will be 0. Any point, pivot or not, okay, random points. So sum of the torque about any point or any axis, okay, will be 0. So you have a choice of picking points. You have a choice of picking points. Now in here, there's this force, and I need to figure this guy out. So this torque from this better not be 0. So our constraint here, our strategy is, if I pick a pivot point, to pick a pivot point so that torque from FA is not 0. If it's 0, suppose I pick a pivot point, this one, okay, then I'll get an equation, okay, I'll get an equation, but it's not going to have a quantity I need for the problem to solve. So that's not good. Now you could have this guy's pivot point. That's perfectly okay. All right. So this will have this lever arm. Axis will be coming out. So this will be lever arm. But then these guys will have lever arms too. So, but we don't know these guys, and we prefer not to calculate them if not necessary. Okay. However, if I put this guy as a pivot point, so if I put this as a pivot point, then these two forces go right through here, and I don't need to compute their torques, right? So that means picking P to be pivot point, okay, we have solved our problem. We'll have torque from N2 equal to 0 and torque from friction force is equal to 0. I forgot to mention that there may be friction force around here too, but because there's no contact, even that don't have to worry about it. So there's only one friction force, or Fs if you prefer. I'm using Fs. So somewhat torque of this is balanced by this, and because we already know this, we don't have to worry about that equation. Just this equation is enough for this problem. Pretty cool, right? Okay, so I need to figure out from here, this guy let's draw it again out. This is the point P, and this is H, and this is the center. That's where so this is the weight, and so from the pivot point, I have to draw 90 degrees to the line of force. So this is the lever arm for weight, and weight, its tendency is going to be this kind of, so tendency will be like that. So this is like a counterclockwise. So this one, just I need to figure out what this distance will be. That distance is R, and over here, from here to here is R, and here to here is H. So this side is R minus H. So this will be square root of R square minus R minus H square. So that just should be equal to 2RH minus H square. So this is the lever arm for weight. And we got a mg times square root of 2RH minus H square, and tendency is that way. How about that guy? So let me redraw it because it's going to be messy. So if I were solving this problem in the test, I wouldn't be redrawing it. I would just so this is the force, and this is the pivot point. So we want 90 degrees onto that, and we want this is the distance we want now. We want this distance. So this is R, and we already know this one was R minus H. So this distance is 2R minus H. So this is the R perpendicular to FA. And so FA times 2R minus H. And its tendency is, this is point P is trying to rotate this way. So this guy's tendency is that way. So this torque really is balanced by these two torques. They add up to 0. So if one is plus, one is minus. So this is T1, T2. So you have a T1 minus T2. One is plus, one is minus, equal to 0. So torque 1 equals torque 2. So whatever we want to write it, you should write it. And so we have, so this equation becomes, so solve is FA is very easy. Square root of 2RH minus H square over 2R minus H times mg. Of course, it's 2R can't be H, otherwise I can't divide, right? So like if this height is way out there, then this will never climb, but mathematically it would not make sense either, be dividing by 0. So that's the answer for FA. How about for the B, the other situation? For the other situation, this doesn't change. So for the other situation, instead of this get replaced by that. But point P is here. So if you draw the 90 degrees from here, So we need to get this distance out. And we already know the mg was this way. Mg was halfway there. We already figured that part out. And so this, from the symmetry, this is equal to that part. So this part was already over here. And we need to go we need to go a little bit further, right? I mean, look at this. This is this corner to this thing. So this was R, and this is R minus H. But is it going to be the same thing over there? Let's draw a bigger picture. So let me draw a bigger picture. In bigger picture, you can clearly see that when this FB is here, it's not 2 times this. So this one was square root of R square minus R minus H square. But then this one, if you start from this line, the center line, to over here, that's just one radius. So I need to add these guys. So R perp of FB will be R plus square root of 2RH minus H square. So tau of the B will be FB, this number, R plus square root of 2RH minus H square. Okay. And this guy's sense is that one, and the other one is mg2 square root R minus H square. So tau, this must be balance mg square 2RH minus H square, and this guy is trying to do that. Mg is acting that way. So this one is trying to do that about point P, and this guy is trying to do that about point P, and they're balancing. So FB is going to be just mg 2RH minus H square R plus 2RH minus H square. Okay, so I'm gonna this is all I wanted to say. Just a request that if you like this kind of explanation, then please subscribe to this channel so you get notification that I post new videos. Other than that, have a good day. Bye.